Welcome to Design of Machine Element 2, Module 5, Lubrication and Bearing. In this class, we'll discuss some of the important problems with respect to sliding contact bearing, that is nothing but general bearing of a different angle, that is full general bearing, partial general bearing, as well as we have to solve some of the problems on thrust bearing. So problem is very simple. So directly we can solve with the help of Mahadevan data and most of the problem, but we have to use some of the charts. It is nothing but temperature viscosity relationship, as well as Mecchi investigation. So for that purpose we have to use some other data and book, that is Lingaya. That data and book is already I have shared in Google Classroom. So only a few sheet that can be sufficient, but you have to make note that one of the important things, that is whatever the notation that is used in Lingaya data and book, so that is entirely different than Mahadevan and Balve Reddy data and book. So while solving problem, you have to carefully you have to solve, because whatever the notation, some parameters they given in millimeter Newton per millimeter square, some parameter they given in Newton per meter square. So in symbol and description, so whatever the symbols they are given, so you have to go through properly, because the same value of symbol, so that will be different in Lingaya data and book. Similarly, whatever the units also in the equation used, because equation you may feel entirely different, but final answer, if your substitution is properly, you will get the same answer. So that is one of the important note. In the design of sliding contact bearing means, you need to find out, already I explained in the last class. So that means we need to find out selection of oil, you have to find out, then lubrication number you have to type of lubrication you have to check which type of oil, then operating temperature of the bearing you have to find out, then coefficient of friction. For that purpose you have to use a different equation. Then you have to find out bearing pressure, dimensions of the bearing, mainly a diameter of general length of the bearing, and power loss you have to find out, then frictional torque, then heat generated, heat dissipation, everything, all the most of the equation you can find in Mahadevan and Balavi Reddy data and book. Only few charters if they ask specifically in the final exam, so then you can go through Lingaya data and book, so that also will provide in the exam. So that is about how to solve problem with respect to sliding contact bearing. So in that two important problems, one is general bearing, second one we have to find out problems on thrust bearing. Let us start first problem. So that is very simple problem. You have to use Petrov equation. So whatever the derived equation that we derived in the last class. So I'll read the problem. Determine the power loss for a Petrov bearing 100 millimeter in diameter and 150 millimeter long. The radial clearance is 0.05 millimeter. The speed of journal is 1000 rpm. The lubricating oil is SAE 10, and the bearing operating temperature is 60 degrees Celsius. So that is the problem given. Very simple. Usually they ask for 8 to 12 marks, whatever the problems from this chapter. So here what are the given parameters? So diameter of the bearing, so it is always given, so that is 100 millimeter, and length of the this is general bearing, so 100 meter in diameter is nothing but diameter of the journal, so that is denoted by small letter d, because we are not using any diameter with respect to bearing. Then 150 long. L is nothing but length of the bearing. So L is nothing but length of bearing, and radial clearance is denoted by small letter C in Mahadevan and Balve Reddy. So notation may be different in Lingaya data, so don't get confused. So radial clearance is given, that is 0.05 millimeter. Speed of journal is given, that is 1000 rpm, because in Petrov equation, whatever the equation, so that uses n should be in small letter, so that is nothing but rps. So that's why you have to convert rpm into rps, that is nothing but n divided by capital letter n divided by 60, so you will get 16.667 rps. So that is about speed in rps. Now, selection of oil. The operating temperature of the oil is given, so that is mentioned here, 60 degrees Celsius, and they have given whatever the uh, lubricating oil, so that is SAE 10. For this purpose, you have one table, so that is from table 15.1, that is from page number 363. So for SAE 10, whatever the value of type of oil, so that is oil B, so that you can find from table 15.1, that is from 363 page. Now from figure 24.2, so that is viscosity versus temperature value, the chart you have in Lingaya data book. So that's why this data, whatever the, you need to find out viscosity from that chart. So that chart is depend on the operating temperature, and whatever the oil used, that is whether it is A, B, C, D, E, F, whatever it may be. So based on temperature and type of oil, so you can calculate whatever the absolute viscosity. So absolute viscosity unit, that is Pascal second, or kg per meter second, so or Newton second per meter square. So these are the unit for SI unit. So you have to use always in Newton meter per second square. You are not supposed to convert it into millimeter, because that always you have to keep in. So you can see that with the help of Mahadevan data and book, whatever the description and unit, so that is available in page number 349. So from that figure, or that temperature viscosity relationship, so you will get the value Z, that is 14 into 10 to the power minus 3 Pascal second. That value you have to use in Petrov equation. So Petrov equation is given with the help of this equation 15.4a, that is from Mahadevan and data and book. So you can use Lingaya data and book as well as, but the notation will be different, as well as whatever the equation nature will be different, but final answer will get same. So because we have to use this data and book, because they will not provide plenty of data and book in the exam, so they will provide only few sheets, that is some of the charts they will provide. So you have to use anyhow this data and book. Most of the problem, 90% of the problem you can solve with the help of this data and book. So based on this equation, so Z is nothing but viscosity, that is absolute viscosity, and whatever the unit is Pascal second. N is the speed of rotation in RPS. P is nothing but bearing pressure, it should be in Newton per millimeter square, and R is nothing but radius of the journal, and C is nothing but radial clearance. So with the help of Petrov equation, you have to find out whatever the unknown. So Petrov equation, the P value they are not given, so we have to find out, because they told to find out what is the, determine the power loss, you have to find out. So after substitution, 2 into pi square into 10 to the power minus 6, so z value, so that will get from temperature viscosity relationship from Lingaya data and book sheet. It is one of the important chart based on type of oil. So we got B value, B type of oil from the table, 15.1 into 16.67. N you have to always keep in RPS. P is nothing but unit bearing pressure, so that value you cannot calculate, you keep as it is. Into R value is given, that is radius, it should be in millimeter. 50 divided by C. C is nothing but radial clearance, so that value also should be in millimeter. And after substitution you will get 4.6059 into 10 to the power minus t divided by P. So after this, power loss we have to find out, because power loss you have to find out. To find out power loss in your data and book, the equation is 15.6 J. 15.6 J. You can find this equation from page number 356 in the Mahadevan and Pallavi data and book. So based on this equation, we have to substitute now the value of coefficient of friction, so that can be calculated with the help of Petrov equation. You have to substitute here, so that is in place of F. So there will be a different uh, many types of equation to find out coefficient of friction. So one of the important equation is Petrov equation, as well as you have one more, that is Mecke equation. So but they have mentioned in the problem you have to use Petrov equation to find out power loss. So that's coefficient of friction, always you have to find out based on Petrov equation. Now power loss can be calculated, that is denoted by Hg. So F value is already calculated, 4.6059 into 10 to the minus 3 divided by P into uh, P. So W, so W you have to write in terms of pressure into area, so that we have to write. So value bearing pressure equation is nothing but bearing pressure equation is W divided by 2RL. So that is from equation number 15.6C, that is from page number 355. So if you use that one, W can be written as P into 2RL. So P into 2RL. So R is nothing but radius of the journal, and L is nothing but length of bearing. So that is why this P bearing pressure and whatever the numerator and denominator P will get cancel each other. So you can cancel now. Into velocity, so velocity always you have to use equation pi d n divided by 60,000. So when you use n, it should be in capital letter, that should be in RPM. You are not supposed to use RPS. If you use RPS, it should be 60, sorry, it should be 1000. So that is the one of the important thing you have to note down. So velocity equation is pi d into capital letter N divided by 60,000. So after substitution, you will get power loss value as 361.746 watt. So this is the final answer for this problem. Usually they will ask such problem based on Petrov equation. Either you have to find out coefficient of friction, or you have to find out any one of the unknown, like maybe you can calculate Z, or maybe you can calculate the P value. Sometimes they will give you a load, because unit average bearing pressure is given by P equal to W divided by 2RL. So based on this, they may tell you to calculate load also, or velocity also you can calculate. Similarly, you can calculate radial clearance, radius of the journal. So whatever the problem, with the help of Petrov equation, so you can solve many different types of problem this is one type of problem. So we are not going to solve different types of problem based on Petrov equation. I think this is one is more than enough, because most of the problem they'll ask to find out what is the coefficient of friction if you using Petrov equation. So that is the usually nature of the problem. So this is about first problem. Next we'll move towards second problem. So there you can find some more different types of unknowns. So that also we'll discuss in next problem. Next problem, a full journal bearing. So one of the important thing, full journal means whatever the angle, so that will be 360 degree. A full journal bearing 50 millimeter in diameter and 50 millimeter long, operates at 1000 rpm and carries a load of 5 kilonewton. The radial clearance is 0.025 millimeter. The bearing is lubricated with the SAE30 oil, and the operating temperature of oil is 80 degrees Celsius. Assume the attitude angle as 60 degree. I think this is wrong. This is not Celsius. 60 degree. Determine first one bearing pressure, second one Sommerfeld number, third one attitude, fourth one minimum film thickness, fifth one heat generated, sixth one heat dissipated if the ambient temperature is 20 degree Celsius, and seventh one amount of artificial cooling if necessary. So this is the one of the most important problem. It covers almost all types of unknown, starting from bearing pressure, Sommerfeld number, attitude, minimum film thickness, heat generated, heat dissipation, and amount of artificial cooling. So viscosity. These are the some of the important unknowns. Along with the you may have to find out flow rate or flow variables. Many things are there in your data handbook. Directly you can solve. Now how to solve this problem? Before that I will see what are the given parameters. So L is nothing but length of bearing, so that is given here. The length of the bearing is 50 long, so it's nothing but 50 millimeter, and the diameter of the journal bearing having diameter 50 millimeter is denoted by small letter, and load, whatever the load to be carrying, so that value of load is given here, that is denoted by capital letter W is equal to 5 kilonewton, and radial clearance, so that is nothing but small c value is given here, c equal to 0.025 millimeter, and operating temperature of the bearing. So operating temperature is always denoted as T naught, is 80 degrees Celsius, because based on operating temperature of the bearing only you have to find out viscosity from the temperature viscosity chart. So usually that is available in both the data book, but if you use Lingaya data book, whatever the value directly you will get in absolute viscosity. So if you use Mahadevan data book, you will get some kinematic viscosity or centistokes something you will get. So to convert that one you need again density and all. So better always you go with the Lingaya data book. The one sheet is more than enough. Then TA is nothing but ambient temperature. Similarly, TB is nothing but bearing temperature, is not given here. And type of oil, it's very important in lubrication and bearing. So very important is oil with the viscosity. Here type of oil is SAE30. So this is one of the important condition to find out which type of oil, whether oil is A, B, C, D, E, that you have to check. So bearing pressure, first we have to find out, that is first question. The equation is 15.6 C in your data and book from page number 355. So that is given by small letter p is equal to w divided by 2 into r into l. So w is given, that is 5 kilometer, 5 into 10 to the power 3 divided by 2 into r. So r is nothing but a radius of the journal. Diameter is given, so you have to divide it by 2, that is 50 divided by 2 is nothing but 25 into L. So L is nothing but length of the bearing, that is 50 millimeter. So after solving this bearing pressure, you will get 2 Newton per millimeter square. So that you will get from equation number 15.6 C. This is your first question. Now second one, Sommerfeld number. So Sommerfeld number in your data and book, there will be two equations. One is without side leakage and with side leakage. If they are not mentioned in the problem, always go with without side leakage. So that will from equation number 15.6a from page number 354. So based on that equation, it is Sommerfeld number. It is denoted with the S letter, capital letter S. It is nothing but R by C whole square into Z into capital letter N divided by P into 10 to the power minus 6. So that is equation number 15.6a. So R is nothing but a radius of the journal, C is nothing but a radial clearance, Z is nothing but absolute viscosity. It should be in Pascal second, and N should be in RPM. So P is nothing but capital letter N is always in RPM, and small letter n should be always in RPS. P is nothing but unit bearing pressure. It should be in always Newton per millimeter square. So if you substitute this equation, you will get Sommerfeld number. But Z value is not given in the problem, so that you have to find out based on operating temperature always. So operating temperature is given, that is TO equal to 80 degree Celsius, and the selected oil number is F. That is from table, one of the important table in your data and book, that is table 15.1 from page number 363. So based on that one, the selected oil, that oil can be selected based on SAE oil characteristics, that is given SAE 30. So that can be used for used as a automobile oil. For that one, the whatever the type of oil, number is F. That is notation of oil in order to check the viscosity from viscosity temperature relationship, that will get from 24.2 with help of Lingaya data and handbook. So this is one of the important sheet in the journal bearing design, that is temperature viscosity relationship. So based on TO 80 degree Celsius, this should be in x-axis, and this is the curve in the chart, that is F. Similarly, there will be A, B, C, D, E, F. So based on F, the y-axis always will be Z value, is nothing but absolute viscosity. So directly you will get whatever the answer. So that you have to trace properly with the help of scale. So because if you if there will be a small variation also, there will be changes in the absolute viscosity. So you have to carefully check what is the value of viscosity. So viscosity you will get from this figure 24.2. The value will be 0.0165 Pascal second. So now you can substitute in the above equation, that is 15.6a. So S can be calculated as 25 divided by 0.025 square into Z 0.0165 into 1000 divided by 2 into 10 to the power minus 6. So whatever the answer, the Sommerfeld number will be always dimensionless number, but if you use Mahadevan and date and book, always you have to write whatever the unit as. Actually there is dimensionless because s and minute both are in time only, so that will cancel each other, so you can write as a number also. So if you use this equation, always you have to write like this, that is 8.25 second per minute. So that is given in uh, starting of your that module in your data and book. So that is chapter number 15 from page number 349. So you can see there symbol and description for Sommerfeld number. It is given always in s per minute. Now coming to the third question, that is minimum oil film thickness from table from figure 24.13a. So you can find L by D ratio, that is L is given, and L is nothing but length of bearing, D is nothing but diameter of journal. So both are 50 here in this problem, so that's why 50 divided by 50 you'll get 1, and S value is 8.25. so if you convert into number, so you'll get 0.1375. So based on this from figure 24.13a, so easily you can calculate delta. So delta is nothing but one of the variable, so delta is given by 2 into h minimum divided by c. So with the help of this relation, delta equal to 2h minimum divided by c, so you can calculate h minimum because c value is given in the problem. So delta you will get from this chart, that is figure 24.13a. So based on this condition, L by D ratio and Sommerfeld number you have to use, because this figure you'll get from Lingaya data and book, this chart. So you have to use Lingaya data and book sheet. So minimum film thickness. So but you can use Mahadevan also, but you have to use some of the other chart. So this will be very easily you can find out minimum film thickness. So after substitution, this one you will get h minimum as h minimum, or it is also denoted as oil film with smallest oil film thickness h naught from equation 15.7b or 15.7a. also you can use some if some of the data are there. So otherwise you can find out based on chart easily. So you can use some other chart also. You will get this value that you have to calculate for full journal bearing. So that is one of the important thing. Full journal bearing means whatever the beta angle. So beta is nothing but angle, so between the journal and bearing. So full journal bearing means beta angle is always 360 degree. So based on that figure 24.13a, so h minimum value will get 6.25 into 10 to the power 3 millimeter. So this is about third question. Now fourth question, that is attitude. Attitude is given by 1 minus h naught divided by c. So attitude is nothing but eccentricity ratio, so that you will get from equation number 15.7b from page number 357. Equation number is 15.7b. So if you substitute 1 minus h naught is 6.25 into 10 to the power minus 3 divided by c value is 0.025, so you will get 0.75. so that is attitude. Now heat generated you can calculate. First we have to calculate coefficient of friction, because heat generated Hg equal to F in FWV. So that is from equation number 15.6j. So before that we have to find out coefficient of friction. If they have not mentioned based on which equation you have to find out coefficient of friction. So always you have to find out using Mackey equation, that is from 15.4b. So it is given by F equal to K into Z into N divided by P into R by C into 10 to the power minus 10 plus delta F. So here Ka value they have given, that is 5, that is given 0.195 into 10 to the power 6 for full bearing. So when beta equal to 360 degree, so that may be varying. So you can see value of Ka below this equation, that is 15.4b from page number 353. So based on different types of beta value, full journal bearing means beta value is 360 degree, and delta F value is there's a small change in uh, friction, so that is given as 0.002 when bearing having L by D ratio lies between 0.75 to 2.8. So you can use one of the important figure, that is 15.5 B to find out the value of correction factor delta F for coefficient of friction. So that is from page number 353. So that value also given below this equation. So now you have to substitute Z value, N value, P value into R value and C value. Now you can substitute all the value. Ka value is 0.195 into 10 to the power 6 for a full bearing, that is beta equal to 360 degree. Delta F 0.02 for bearing having L by D equal to 0.75 to 2.8, that is from figure 15.5b. So because L by D is 1 and P value is 2 Newton per millimeter square, that is you already calculated. Now F value can be calculated, that is 0.195 into 10 to the power 6 into, this is viscosity value you already based on operating temperature of the bearing and type of oil, that is F grade we have selected, that is SAE 30, that comes under F number, the type of oil is F. So for that the viscosity is 0.165 and small letter n always should be in RPS. So RPM is given, so that you have to convert into RPS. Value will be 16.667 and divided by P. P is nothing but bearing pressure 2 into R is 25, that is radius of the journal, and C is nothing but radial clearance into 10 to the minus 10 plus 0.02. So F value will be, it is always dimensionless value, that is coefficient of friction, you will get 4.68 into 10 to the power minus 3. So once you get the coefficient of friction, easily you can calculate power, what is the heat generated. So heat generated using coefficient of friction as calculated by Mackey equation. Now you can calculate heat generated from equation 15.6j from page number 356. So F is nothing but coefficient of friction here, and W is nothing but load, so that is given, and V is nothing but velocity. So velocity we can calculate like this, pi into d into n divided by 60,000. So velocity will get pi into d is nothing but diameter of journal 50, n should be in rpm 1000 divided by 60,000, so you will get 2.62 meter per second. So based on that one, hg you can calculate like this, 4.68 into 10 to the power minus 3 into pi into 10 to the power 3 into 2.62, you will get 61.26. So unit is joule per second is nothing but watt. So the value of heat generated is 61.26. Here one of the main aim is to find out heat dissipation and heat generated, because if the heat dissipation is more than heat generated, then there is no need of any cooling. But if heat generated is more than heat dissipation, then we have to go for artificial cooling. Now Coming to next question, that is heat dissipation. It is given by HD in your data handbook 15.11b. So that is from page number 360. You can find this equation HD equal to KH A dash into TB minus TA from equation number 15.11b. So KH value, so they are given in the data handbook itself. So you can use 14.4 joule per second meter square degree Celsius for air. Similarly for other condition they have given. So if they have not mentioned any condition, always you can select this value for your calculation. Then a dash is nothing but exposed area of bearing housing. So that should be always in meter square. So that equation is given 20 dl into 10 to the power minus 6. So 20 is nothing but this is the uh, equation, standard equation they have given. D is nothing but diameter of journal, and L is nothing but length of bearing. So after substitution you will get whatever the area of bearing housing is 0.05 meter square. Now you have to find out with the help of one of the important relationship between the operating temperature and uh, temperature difference between the bearing and atmosphere. So that is from equation number sorry that you can find from equation number 15.11c. So that is TB minus TA is equal to TO minus TA divided by 2. So based on this relation you can calculate bearing temperature. So that is TB is nothing but bearing temperature, TA is nothing but ambient temperature. So this equation you already studied in heat transfer. That is one mode of convective heat transfer, that is according to Newton's law of cooling is equal to 80 minus 20. So 80 is nothing but operating temperature, TA means ambient temperature divided by 2. So TB value will get 50 degree Celsius. Now after calculating, so HD value will get 17.1. So it means that Hg is greater than HD. It indicates that heat generated is more than heat dissipation. So therefore artificial cooling is required. So heat, whatever the dissipation is very less, so there will be a lot of heat generated. So therefore we have to provide artificial cooling for the bearing. So that is why you have to find out whatever the heat generated and heat dissipation, because this is one of the important design from the temperature standpoint of view. Now coming to the amount of artificial cooling, how to find out what is the quantity of artificial cooling is required. So that is very simple. Hg minus Hd you have to do. So that is 61.26 minus 17.1, 14.16 W is nothing but this much watt cooling is required in order to reduce the friction. So that is one of the important design of general bearing. So these are the important questions that you have to study in the sliding contact bearing. Now coming to the next problem. So this is one of the problem on thrust bearing. So we know what you mean by thrust bearing. So based on thrust bearing under sliding contact bearing, so we have to solve one more type of problem. So I'll read the problem now. The thrust of a propeller shaft in a ship engine is taken by a number of collars integral with the shaft, which is 300 millimeter diameter. The thrust of the shaft is 200 kilonewton and speed is 75 rpm. Bearing pressure is 0.3 megapascal. Find number of collar required if the outside diameter is 500 millimeter. Power lost, second one, power lost in friction assuming uniform wear. Third one, heat generated in the bearing. So this is one of the uh, when the bearing subjected to axial load, so we call it as thrust bearing. The thrust bearing design is entirely different than whatever the general bearing, that is when general bearing is always subjected to radial load. The thrust bearing design is somewhat relation with the friction clutches. So friction clutch, there will be two case. One is uniform pressure distribution and uniform wear condition. With help of these two conditions, so we can solve friction clutch problem as well as thrust bearing. So that is very important because there is no any other formula, otherwise you have to remember the formula for this one, because they have not given any problems, any formulas with respect to thrust bearing in your written book. So for that purpose we can use whatever the equation from friction clutches that you can find page number 258. So now you can see what are the important data they given. So they have mentioned here, assuming wear condition in your data and book from page number 258, you have two condition. One is uniform wear condition and uniform pressure condition. If they not mentioned in the problems, always you can go for assuming uniform wear or assuming uniform pressure condition. Now FAW, AW means axial load and W indicates uniform wear. So the axial load is given, that is thrust load is nothing but axial load, it is given 200 kilonewton, and maximum pressure, because in that expression pressure will be maximum, so maximum pressure is given, that is 0.3 megapascal, is nothing but bearing pressure, and N will be speed, that is in capital letter RPM 75 RPM, and DI is inside diameter of the collar, because it is one of the thrust bearing. We call it as in thrust bearing there are two types. One is one is called pivoted bearing, another one is called thrust collar bearing. So collar bearing means there will be a number of collar, you already we have discussed that one. So what is the collar? So for collar bearing we have two diameter, one is inside diameter of the collar and outside diameter of the collar. So inside diameter of the collar is nothing but shaft, usually shaft diameter, so that is 300 millimeters, that is denoted by DI. So outside diameter of the collar is given here 500 millimeter, and we have to assume uniform wear condition. So based on this they have to we have to find out now first question, that is number of collar required if the outside diameter is 500 millimeter. They have given equation for axial load, so that is from equation number 13.9. so that they have given only for a single collar, so you have to multiply with n. So this is equation you can find from your data and book 258 page, because this expression can be used for clutches. We are not using for bearing, because bearing equation is not there in your data and book. So that's why you have to use this equation from clutches. So that's why either you have to remember or you can use, because there will be n is not there, you have to multiply with n. So that is half into 5 into P max into DI into D outer diameter minus inner diameter into n. So n is nothing but number of collars, so that you have to find. So axial load is given 200 into 10 over 3 is equal to half into pi. P is given, that is bearing pressure. DI is 300, D naught is 500 minus 300 into n. So n is nothing but number of collar. You will get 7.07. Always consider next higher value, because number of collar will be whole numbers. Now second question, you have to find out power lost. To find out power lost, first you have to find out what is the torque transmitted by that by the bearing. So that you have to find out first. So for that purpose, you have to use this expression from your written book 13.9 E expression. So 9F means that is with respect to clutches by considering number of pairs. So that will be different. So that purpose you have to use 13.9 E. So T equal to half mu into FAW into DMW. So DMW is nothing but mean diameter of the collar, assuming uniform wear condition. So if uniform wear condition means mean diameter can be calculated DO plus DI by 2. If it is uniform pressure condition means mean diameter of collar can be calculated 2 by 3 into d naught cube minus di cube divided by d naught square minus di square from equation number 13.9c. Now first find out mean diameter of the collar d naught plus di divided by 2 because the uniform wear condition. So mean diameter of the collar is 500 plus 300 divided by 2 is equal to 400 millimeter. So now assuming coefficient of friction, if it is not given, always assume 0.05. Actually you can assume from 0.03 to 0.05. So always you assume 0.05 if it is not given. So based on material, you can select from this table, that is 13.4. So this table usually we can use for friction clutches, but bearing also you can find some of the value, but always you use the 0.05 as coefficient of friction if not given. Now you substitute all the values, so you will get torque as 2 into 10 to the power 6 Newton millimeter. Now you know what is the power equation with respect to relation between the power and torque. So torque is given by 9.55 into 10 to the power 6 P into kilowatt divided by N. N is the speed in RPM. P always you will get in terms of kilowatt. Now you can substitute that one. 2 into 10 to the power 6 is equal to 9.55 into 10 to the power 6 into P into kilowatt. So W should be capital letter here. So it should be in kilowatt. You will get 15.7 kilowatt. So this is the second question, power lost. And third one, heat generated you have to find out in the bearing. So heat generated in the bearing is always equal to power lost in the friction. So therefore heat generated will be equal to power lost in friction. So therefore heat generated is given by Hg or same as P. It should be in kilowatt. The value will be 15.7 kilowatt. So this is the one of the type of problem from collar bearing, or we call it as thrust bearing. So similar type of problem sometime they will give you based on uniform pressure condition. The only change is equation. In such cases you have to use equation 13.9a in page number 258, and whatever the mean diameter of the collar will be different. So rest of the procedure will be same. So usually this is the nature of the problem with respect to thrust bearing. Next class will solve some of the problems with respect to again sliding contact bearing or journal bearing, and some of the problem second part, that is anti-friction bearing, how to select ball bearing as well as roller bearing from the manufacturer's catalog. So that also very important problems from the exam point of view. Thank you.